Imagine wildfires wiped out 96% of a forest. That's what's happened underwater along California's north coast. Healthy kelp forests once fed and sheltered marine species, but recent warm water events have triggered a chain reaction, wiping out the predators for purple sea urchin. Without predators to contend with, these urchin have skyrocketed in population, devouring nearly all of North California's kelp and leaving urchin barrens on the sea floor, where urchins survive starving in a zombie state for decades. Restoration teams have begun removing these urchin by hand, but with very little uni to offer, their market value is minimal, and instead these urchin are left to rot. In Mendocino, recovery efforts are underway, but they face challenges securing long term funding, as well as sustaining government support and public visibility around kelp restoration. This project seeks to shift the focus toward creating demand for urchins in other sectors, like combating the climate crisis. Urchin naturally sequester CO2 or carbon dioxide through a process called biomineralization, turning what would be atmospheric emissions into the stable calcium carbonate that builds their shells. The additional value of this species is underscored by the edible uni that can be harvested inside. Urbon is an urchin centered carbon capture system that uses the urchin to its fullest potential at every stage of its life cycle. We begin by collecting urchin off the California coast before moving them to a designed aquarium environment where they grow in a healthy setting while actively converting CO2 emissions into the calcium carbonate that builds their shells. When these urchin reach a marketable scale, their uni can be served as a culinary ecological experience, while their calcium carbonate shells can be reused across a variety of sectors. Collectively, these new uses for urchin create greater buy in and demand, as well as facilitate public engagement around the issues plaguing our marine environments. The tank that we've designed for Urbon mimics the form of the purple urchin shell, from its circular characteristics to its pentaradial symmetry and polymer balloons that house CO2 on the exterior of the form, mimicking the spines of the purple urchin. Internally, the system uses integrated multitrophic aquaculture, or IMTA, to simulate a biodiverse portfolio of marine species, which includes everything from bull kelp, which absorbs CO2 through photosynthesis and provides a food source for urchin, to sea cucumbers that recycle waste and sediment, as well as a variety of other species. In application, we identified Mendocino wineries as a relevant case study for the use of Urbon. California wineries currently emit nearly 500,000 tons of CO2 annually, and the adaptation of this technology by such a prevalent industry would signal greater change across the board. In the context of a winery, we envision scaling Urbon to a tank roughly 11 feet in diameter to capture as much CO2 as possible. The system works by displacing CO2 in fermentation barrels and moving that CO2 into the balloons that sit on the exterior of the shell form. As these balloons fill, regulators measure pH inside of the tank and diffuse the CO2 accordingly down through internal tubing until finally they reach diffusers where they're turned into tiny bubbles that the urchin can convert to calcium carbonate. Simultaneously, bull kelp and coralline algae help to sequester CO2 through photosynthesis and provide a food source for urchin. Once these urchin have reached a marketable scale, they can be harvested from the tank in the fermentation space and moved to a tasting room where their uni can be paired with wine and users can actively engage in the kelp restoration project via a culinary experience. For kelp restoration, Urbon turns urchin into valuable assets, helping fund restoration and research and facilitating greater visibility. For wineries, it mitigates CO2 emissions and improves workplace safety while creating new culinary pairings, enriching vineyard soil through the use of calcium carbonate. The applications beyond the winery are vast. Urban's carbon capture technology can be applied everywhere from industrial plants to greenhouses, while its calcium carbonate can be applied to agriculture as well as creating sustainable construction materials and cosmetics. Additionally, Urban functions as a social education and outreach tool. These tanks could be installed at museums like San Francisco's Exploratorium, pictured here, as well as at a smaller scale used in a classroom setting to teach students about how these marine environments should function in a healthy manner. Ultimately, kelp loss is a human driven problem derived from our decimation of the global climate. Urban reframes the purple urchin as a solution rather than a problem as we attempt to address both kelp recovery and combat the climate crisis more broadly.